Okay, so what we're going to want to do, we want to break this up in such a way that we can extract our formulas from it. Okay, so we have a word problem and we're create equations of a line, right? Both general form, so this is our y equals mx plus b, or general form, which is ax plus by equals c, right? So both these can occur. This one, so right? So this is slope-intercept, slope-intercept, and this is general, right? So Natalie must go away to study abroad a year. She has to empty furniture, furnished apartment that she is renting and store her boxes in the storage facility. She uses two types of boxes. So she has that one and that one. Storage box takes up this much space. Fine. She stores a total of 40 boxes. Great. How many boxes of each type will she use? Well, here we go. So you know X we'll just call the boxes with a volume of 0.36 meters cubed boxes, right? So that's that volume of boxes. Y will be the other volume of boxes, so 0.048 m3. But this is like the number of them. So this is number of these boxes. Number of these boxes, like 1, 2, because this is a particular volume. Boxes. Right? These are talking about number of, you can even call this, instead of that particular number, we need the number, because later we're going to use it, but we could call this a small box versus a big box, right? So I'll just put in parentheses, small and big box. So really, how many of those do we need, right? So we do know that she has x plus y equals 40 boxes. We just don't know how many of the small and the big she has, right? Okay. So the other equation that we can say is we do know how much the volume of, because we're given a total volume of space, right? So she needs to fit it into this 1.62 to the meters cubed of space. Well, we have how many small and big boxes can fit into that space? Well, that's now what we're going to look at. So we're now going to say we have 0.36 or 0.036 of x, those number of boxes, plus you'd have 0.048 of y, right? Because this is the volume you have, right? Because this then is going to tell you, add all these up, and you're going to get 1.62, right? That's your total volume. So this is equation 1, and here's my equation 2. So now all we have to do is put one equation into the other. Now, notice what I'm going to do to make my life a little easier. I don't like dealing with these decimals. By all means, if you want to work with the decimals, you can work with the decimals. It doesn't hurt you. But another nicer way of dealing with it is multiply, because there's 0.62, right? Multiply this whole thing, so both sides. So we're going to multiply both sides. Multiply both these sides, right? This whole expression by 100. So what you're going to get, or actually 1,000. We're going to multiply it by 1,000 because this one's 3 decimals. So that's tens, hundreds, thousands, where the 6 is, right? So then that would mean my equation 2 would turn into something that looks like this. 36x plus 48y equals 1620. There we go, right? So this is an easier number to work with. Now I can say, use 1. So rearrange 1. Rearrange 1. So this would be y equals 48 minus x. Now what I can do is plug into 2, right? So this one. Plug into, I'll put 3. Plug into 3. So that would mean 36x plus 40 minus x equals 620, right? So that means if I go through it, right? So if I go through this, or yeah, so if I go then distribute this, actually I'll probably need a calculator. So I'm just getting my calculator here. So I'm going to just go clear. This is going to be 36x plus 4. Oops. I got 48 times. So you need to distribute this. So here and here. This is going to be 48 times 40. That's 1920 minus 48x equals 1620. So now what I can do is, it's just, notice I have 36 minus 48. So 36 minus 48. That's just going to be minus 12. So this is minus 12x. But notice what I'm going to do. I'm going to move this one over to here. So I'm going to have to subtract 1920 from both sides, which gives me 1620 minus 1920. I get minus 300, right? Now I divide both sides by minus 12. X is equal to, so 300, let's say divide by 12 because it's positive. So x is 25. Ha! Now we got it. So guess what? We can already use to find, so we know the number, therefore 25 small boxes, right? I need to know, find y, use equation, notice we had this one right here, right? We could use equation 1 or the one that we already prepared right here. This one, which I'll call equation 4. Use equation 4. So that's going to be y equals 40 minus x. I plug in my 25. There's 25. So therefore y is equal to 40 minus 25. Well, 40 minus 20 is 20. So this is going to be 15. Ta-da! Therefore, she uses 15 big boxes. That's it. You're done. That's all we need, right? And this is just big boxes, small boxes. We know the small boxes, this is 0.36. And you know big box is referring to 0.048, I believe, right? This is meters cubed. Meters cubed. So that's it. That's really what we're looking for. So it's actually not that bad. Draw these arrows like I've done. Like if you're moving things across, that is simply, you know, you have to, for this to disappear, you have to subtract it. And you're subtracting it from both sides. So you don't have to do it, but I write it in red because I'm keeping mental note that I'm subtracting it from both sides, etc. I can divide both sides by minus 12. I get my 25. That allows me to use number 4, equation 4, and then find that y equals 40 minus x. I can now find that it's 15. There we go, right? I think with these 3 solutions, right, that you've worked on, you should be more than enough prepared for something like this tomorrow, right? So this is the idea of being able to transfer it from a word problem into a system of equations, right? Because that's what we're working on, right? Just make sure you're making a statement like this. Now remember, memory aid, 1 page, 1 side. That is a must.